What is the purpose of the Transparency Exchange API? Well, the big challenge I think that we have as a industry, next slide, please. The challenge that we have as an industry is that the supply chain is complex, and there's just a general lack of standardization in terms of how do we share not just the supply chain artifacts, but the intelligence itself, and do so in a way that is completely automated, right? With that, the mission or the vision of this project, next slide, please. The vision of the Transparency Exchange API is to develop a seamless API that allows not just for automation, but the autonomous publishing and searching and retrieval of meaningful intelligence, not just the supply chain artifacts like SBOMs and CBOMs and that sort of thing, but being able to go deeper and not necessarily have to consume all of these artifacts. And in the process, with all of this increased transparency, we hope to foster trust and reduce barriers to SBOM adoption in the process. Next slide, please. So what we expect once the Transparency Exchange API has been developed, has been ratified as an international standard, and has been adopted by open source and commercial offerings, the outcome that we expect is that at the end of the day, we'll have a universal API that allows us to share all of this intelligence. It's going to accelerate collaboration. It's going to help us with all of our different compliance efforts, whether it's SSDF, CRA, etc. And more importantly, it's going to provide some actionable insights, which currently, if you're just consuming SBOMs today, it's really challenging to do. All of this is going to help us as an industry minimize risk and increase resilience in the process. Next slide, please. The Transparency Exchange API is broken down architecturally into 5 discrete buckets of things. Top left, XBOM, any kind of bills of materials, whether it's an SBOM, CBOM for cryptography, HBOM, all the inventory related things. Followed below that is CDXA. This is attestations. Attestations can be a loaded word and can mean a lot of different things depending on context. So let me phrase this. In this context, we mean things that organizations attest to. For example, in compliance of a regulation or in compliance of a standard. For example, being able to attest to one of the PCI standards, or being able to attest to an internal company standard, or some kind of industry or regulatory standard for every part of a development process or any other types of process. The attestations are really, really popular when it comes to procurement use cases. Okay, graffiti. The upper right, VDRs and VEXs. VDRs and VEX, again, we have a problem with sharing. The challenge is that consumers really don't know where to get the SBOM from today in an automated and autonomous way. And likewise, being able to publish a VDR or VEX is fairly elementary, but being able to consume that in a completely autonomous way is just not scalable today. So we aim to fix that with VDR and VEX support in this API. PLM, or product lifecycle management, is a real thing. And this is really what the Common Lifecycle Enumeration, or CLE, is about. We plan to expose the CLE in the Transparency Exchange API. And this is going to have a lot of different benefits, ranging from, end of life into support, that sort of thing. But more importantly, for things that occur during M&As or other types of life cycle events where either the product gets renamed or rebranded, or these types of things which make naming hard. I'll follow that up with Insights, which is the bottom slide. Insights is really a way to ask the API questions. I've talked to hundreds of organizations, and the overwhelming majority of them, they honestly just want very simple questions asked. And all of the effort to consume SBOMs and apply VEXs and all this stuff is a lot. The barrier to entry is very, very hard. And that doesn't really satisfy the types of questions that they honestly want answered. So that API, those 5 big buckets of things, is really what we're going for. Now, all of this is being standardized within TC54, which is a ECMA group. All of our work is community-based. So all the real work starts with community, and we have a formal standardization process that both the OWASP Foundation and ECMA International have co-developed. And we are using this model for TC54, and ECMA is using this model for other community-based specifications in the future, which is absolutely fantastic. CycloneDX is part of this group, but right now we are focusing a lot of our efforts on package URL and VERS, the Transparency Exchange API, and coming soon, the Common Lifecycle Enumeration. So visit tc54.org if you are interested in participating in any of these efforts. Again, everything is open for the community development aspects, but like most standards organizations, you do have to be a member of ECMA to participate at the TC54 level. But if you're interested, please reach out, let me know. And with that, I will get out of the way and let the experts take it from there. So welcome. We're glad you're here. Thanks.
We're going to talk about the Transparency Exchange API. I'm going to start with an overview. After that, Anthony is going to talk about the object model that we've chosen for the API. So, like Steve said, the problem is that we need to automate here. We have many customers that need to access transparency documents from a lot of vendors, and a lot of vendors have many, many customers. And we can't have a situation where people manually download by logging into a support portal, right-clicking, download to downloads, and upload into another application. We need to automate the flow here, especially for VEX files. So what we looked into is a discovery, trying to find the services for a specific product or vendor, the identification and authentication to retrieve these documents. And we're looking for a solution that has to scale globally. And now we focused on a lot of different use cases. We'll look into them in a bit more detail soon. But as a customer, I need to get attestations from all my suppliers, both commercial and open source. As a manufacturer, I need to get them from upstream suppliers, both commercial and open source. And interesting enough, we didn't have this really on the radar when we began, but open source projects also have upstream components that they build upon and downstream users that they need to help protect. We looked into a lot of different documents, and I found this a while ago, and it's very, very interesting to see that what we're doing is what CISA is calling a high sophistication level of SBOM sharing. But this is something I strongly believe we need in order to scale this process up and get it into our processes. And while the SBOM is in the limelight right now, many people are talking about the SBOM. It's not only about SBOM, it's about a lot of different artifacts, and as Steve said, also the insights, the ability to reach the data and the conclusions in the data. So what we're looking for is a standardization, an API or an HTTP level, and a discovery scheme to be able to find the services we need to reach. We have divided this into a couple of components. We have something we call the Transparency Exchange Identifier, which is a unique identifier for a product that's sold either on the consumer market or the business market. We have various indexes we're going to go through later, and something we call the T collection, which is for a given version of a given product, the number of artifacts that is reachable. The use cases we looked into, they're all available on our GitHub repo in our document. But let's consider a few of them. We have a retail customer. Alice bought a gadget in the gadget store, and the gadget contains a full Linux system. Where can she find the SBOM and the VEX files and updates for the gadget? A business user has the same problem, but on a different scales, because they buy a lot of products from a lot of vendors, and they need to manage this more or less automatically and be able to get reports. The next time we have something like Log4j, they need to know where that exists in their IT infrastructure. We also have regulators. They need access. In Europe, I'm sitting here in Stockholm. We have the Cyber Resilience Act coming soon. And if we have products that will require certification in that class, the regulators will want to have access to my SBOMs and my VEX files regularly and automated. We also have potential customers. The Cyber Resilience Act covers a lot about insight before purchase, being able to evaluate products and vendors from a cybersecurity perspective. So some data may be available before purchase, and we're looking into that as well. Open source usage is interesting because the same functionality, the same base product, like the Asterisk open source telephony PBX, is available from many different sources. So as a user, I would like to be able to evaluate these sources, these distributors, and see who has the most up-to-date, who has security fixes, apply them, and who can provide me with the most secure version of service. Later on today, we're going to talk about libraries and their role, but a developer needs a library, an open source or commercial, and we need insight into that. What other libraries and components are required in order to integrate this into my product? How are they handling all these artifacts, the security updates, the third-party dependencies, and so on? So we're looking into this. We divided Project Koala into two different steps. One is the basic retrieval of artifacts. We have a publication API and a consumer API and a discovery mechanism. In this architecture, we also integrated the common lifecycle events. I'm going to mention that a bit more, but that's another OWASP project. And we're looking both for in-house solutions where a manufacturer publishes information by themselves, and hosted solutions where we buy the T API as a service from a third party. service. In the second step, we'll approach what Steve talked a lot about, the insights, being able to query the documents, not having to download them, reach the data and get the answers we need. This is a high level integration that we're going to look for when we solve the basic distribution. So let's take a look at the identifier. It's always fun trying to invent something new and set up a worldwide systems of registrars and rules and get in discussion with lawyers all over the world. But we wanted to avoid that. We said we need an identifier that is more or less the same for everyone, but includes existing product identifiers, and it's based on a namespace system that we all know, the domain name system. That way we can easily get an identifier out in the market and get it into usage. And it needs to be persistent for a specific product, regardless of version. This is something you print outside the box or specify inside your application if you have a graphical user interface, but it should be persistent. So this is an identifier, not a locator. You use the identifier to locate one or multiple services. We use standard DNS resolution, as everyone does for HTTP. And the manufacturer is the one who defines the identifier, not a third party. And we have to remember that one single product can have multiple identifiers, could have barcodes, could have UID, article numbers on purchase orders, and other things. So we try to create versions of this TEI identifier that supports EN barcodes, SWID tags, package URLs, and other things that already exist. And we're very open for dialogue and help with making this happen. So one example how this can look, this is a URN. This is something, identifiers that is used, for instance, for ISB book numbers. Here's an example where we have a domain products example com and an identifier, which is a basic UID. And this way, as long as we have a unique domain and not everyone use example com, and we set up a unique identifier, we'll get a globally unique identifier for a single product in a very simple way. And the question is, how do we get this out to customers? Well, it could be QR codes on packages, on the invoice, delivery note, in an about box if we have a graphical user interface, or in the support portal. There'll be many different ways to get the transparency exchange identifier. In the API, we also discussed authorization and authentication. The authentication will be done with an HTTP bearer token, and we will follow the same way of doing this as is used in OpenID Connect and OAuth 2, where the token is basically a JOT structure that can contain metadata about the customer and the authorization levels for that. We will not specify the content of the single token, but we will specify that you'll have a token and how you're going to use that in the HTTP API. But this is something for the actual implementation to sort out. So a T platform could look like this, that you have a storage, which is either included or external to the T service. We have a publishing API, and that could be many different things. It could be integrated into your platform, or you could be using the API we are defining. But on the other side, that's where we have the most important part, the consumer API. This is something that we would like to see implemented in all kinds of software that manage your inventory, that download and parse and work with your SBOMs, VEX files, and other attestations from your upstream providers. We are in discussion of various integrations to transparency logs, because we believe in various niches that this will be really important and for the trust of the vendors to have a transparency log, so we get immutable actions. We see whatever happens on the vendor side. And there could be, of course, many different models. You could have an internal T service, which is integrated automatically to a CI/CD, where we upload all the artifacts so that compliance can actually take a look and verify. We could have an official outside-looking T service where you have the external SBOMs and other artifacts as well. Or you could use a third-party T service as the official customer fronting service. We started to look into various publication workflows in order to sort out the requirements for the publication API. And we see that there's a need for automation from a CI/CD systems, but in most cases, we realize that before publishing anything towards the customers, an internal compliance or legal or some other service will need to approve. There needs to be a release process to publish something on the official public-facing T service. We could see the integration happening in many different ways. I won't go through all the details. You'll get access to the slides later. An important part of all this is the common lifecycle enumeration. As I said, it's a separate OWASP project, but we're following it very closely and we're cooperating with them. But they will actually provide us with the ability to publish data about the lifecycle status of a product or a component. So we can state that this component is end of life, end of support, end of security fixes, or some other statuses. This could be part of the SBOM. It's definitely part of the Transparency Exchange API. The package URL is an identifier that's used frequently in CVEs on osv.org and other places. And in, of course, in software bill of materials. It's an identifier used for vulnerability management. It works very well in combination with the Transparency Exchange identifier, but the package URL is not primarily built for discovery, which is the primary purpose of the Transparency Exchange identifier. As Steve said, we're both working with integration into ECMA, so we're in close discussions with the package URL project as well. So where are we? Well, we have covered the generic models. Anthony will very soon start talking about the object model. We have documented use cases. You can find them all on our GitHub repo. We started working on OpenAPI, and we have come a very long way. We still have a lot of discussions, which is a good thing. We covered and documented a lot of ideas, showed you a few slides here on the publication workflow. We have the ideas on authentication and authorization, but it's not really documented in GitHub. But we feel that very soon we can start working on implementations and see where that takes us. So what we believe is that OWASP T is going to be the standard for Transparency Exchange. We want customers to require it. We would like to see it part of the Cyber Resilience Act horizontal standards here in Europe. We believe it fits nicely with the worldwide legislations for software supply chain security. And as Steve mentioned earlier, we're looking forward to have hackathons. We're discussing having one around FOSDEM in Brussels, and a second one later on with OWASP Global AppSec EU in Barcelona at the end of May. So we're hoping to meet you there. If you want to join the work, you're very, very welcome. We have bi-weekly meetings, and we have a very lively Slack channel. You'll find all of that on this URL. And as Steve said, it's a very open process. We like that you're members of OWASP, but it's not a requirement. And all the work in creating the standard is happening within OWASP. Then we'll bring it forward to ECMA that has special rules for participation, as mentioned previously. Thank you very much. I'll hand over to Anthony Harrison here.
Right, you got me? Yes, you can hear me. Can we have the slide, please?
Oh, sorry, did I lose the...
Yes.
Paul. Slides.
You've got them, yeah.
Yeah, something happened, so I lost them.
There you are. Yes, yeah. Oh, happy koala. Okay. Right. Good afternoon, everyone, or good morning, depending where you are. Okay, so as Olle said, we're just going through where the data model is in a very open way. You know, this is obviously needs to be developed together by the community to make sure it delivers what we all need. So next slide, please. So I think Olle's described really the top level in terms of how we get from a product to an identifier, the index. What I want to talk about is the bottom idea, bottom set, which is how we go from that index and then get to those key bits of information, your SBOMs, your attestations, etc. How you map from your product down to your actual documents. Next slide, please. So I'm going to do this through a few simple examples. So let's think of a very simple product, an intelligent light bulb. So that will have a TAI. That will then point to the T index. And the T index will have a list of versions that product will have gone through. And then from each version, that will then link to the collection of the artifacts relevant to that version. So you can see that in this case, version 2 is the current version. Version 1 has been marked as out of support. And version 2 is reporting showing the collection of the bombs, attestations, certificates, VEX documents, etc. And there's also a version 2.1, but maybe you haven't upgraded your product up to that version. Next slide, please. And this is a slightly more complicated product, which actually has maybe 2 components. Maybe the product is an integration from 2 vendors, 2 manufacturers, and each of those products components will have their own index, T index. So when you get your product, you may get multiple access to multiple collections. Next slide, please. That's basically very much the same, I think. Just saying where you may be getting the index from different sources, different websites. So yes. Okay, next slide. Okay, so let's use some. We have some 3-letter acronyms: TPIs, TLIs. So TPI is the product index. So that is your index into your leaves. And then that will then go into the leaf index, which will identify the particular versions that product has. Then you get to your artifacts, and you'll have a list of artifacts. At this stage, we're just looking at the list of the artifacts. We're not looking at the contents of the artifacts. That's really where the insights will come to. So that's obviously the future where we want to get to. Next slide, please. So if you have multiple versions of a product, you will have multiple collections, version 1 and version 2 in this instance, but you may have common documents, artifacts that are shared between collections. So we need to make sure that we can have the same artifact in multiple collections to be shared. So for example, like in this case, an attestation against maybe a standard. Next slide, please. So obviously we're going to have a lot of metadata. The product index is really a metadata collection. And obviously, as that's the first point of entry, we're going to use probably the TEI as the one of the TEI identifiers. And then we'll have a structured document where we'll be able to extract other bits of information. Now, we may have to identify which versions are available. I think the product index will probably, as we get more and more use cases and more familiar with the implementation, we'll probably find what metadata is useful at this level. Next slide, please. So then when we look at the T-leaf, then we're going to get even more metadata. So we're going to have a reference back to the T-leaf will have a unique identifier. It will have a human readable name and product versions. Obviously, we're probably just going to keep that as a string. It would be really nice if every product followed semver or something like that. But obviously, I think we have to recognize that product manufacturers are going to have some freedom. So we need to recognize a number of different styles. I think the release date's also important. Again, that's needs to be one of the standard ways of referring a date, so it's easily to be interpreted. And then we may want to have a status to say whether this product is in maybe beta release, pre-release, as some manufacturers let early adopters have access to. We will have a different index when we change the major version, as we'll see here. And obviously we have the list of collections. So we're going to have a collection of artifacts that will then be referenced from the leaf. So a collection is really a URL. And that really is where the set of files are going to be. Those files will probably typically be signed for the integrity. But then I'll allow you to get all the files for a particular version of your product. And then therefore you can have access to that, and then you can then start interrogating that collection for whatever use case you need. And this is the sort of things we're thinking about for the collection. Very similar to the leaf. So you can reference back to the leaf, but obviously then we're going to have a few more. Obviously this is where all the documents are, so we need to be able to list the artifact objects, which we'll talk about in the next slide. We also need to have a reference in terms of understanding why a particular release or why the collection is being updated. So that could be, as an example here, it's basically there was an update in the SBOM because we missed a component, or there's a new vulnerability that's been reported and we want to report the status of that vulnerability. So we just need to keep that historical reference of these changes. Next slide, please. And this is the sort of thing we're thinking that a collection would have. Very similar with the integrity, again, more description, and who's actually responsible for generating that artifact. Very similar to the way we think like SBOMs and VEXs already. So hopefully we want to make this, we're very familiar with the people who are already dealing with those artifacts. Again, we're not stating any format. So, you know, in the SBOM world, we're going to support SPDX or CycloneDX or any other formats that may appear in the future. Similarly for VEX, similarly for attestation, similar for any other documents that may be useful to collect as part of the collection. Next slide, please. So I think it's important to think about why you're going to update this collection. It's going to be quite dynamic. Some of the components are going to be very changeable. Some of them are going to be very static. So, but we do need to think about what those reasons are. Currently, we think there's going to be a number of pretty obvious changes, like an update for a VEX, like for a vulnerability, or there's an update to an SBOM. But maybe there need to be others. So I think we need to start, as we get used to using the API, we need to start thinking about what those typical users are. So I think that's really going to come from the community, particularly, look at the use cases that Olle explained in the opening, then think about what those uses might be. Next slide, I think this is the final one. Okay, so the API is trying to be consistent. We're trying to have a very similar style for the index, the leafs, and the artifacts. So hopefully, by defining it through Open API, we enable interoperability in various languages and architectures. This consistency between production and consumption, I think, is very key. But we recognize that this is going to evolve, so we've got to make sure we can have an extensible API and set of definitions. At the moment, we've got a good starting point. I think we then, obviously, as we become closer to more implementations, we'll probably find, as in always, some few improvements. I think that's the last slide, Olle.
Yes. Thank you very much. And we're heading over to Niklas to tell us more about transparency and T in Dependency-Track. Welcome, Niklas.
Thanks a lot, Olle. I think, do I need to be host here, or can I share this way? I think I can share just fine. Okay, just tell me if you can see the slides, please.
Yes, we can. Thank you.
Awesome. Yep, thank you. Yeah, I'm here to talk about how the T could integrate with products or how products that integrate deeply with T might make use of all the features that Olle and Anthony discussed before, and Steve as well. So first, an introduction to what Dependency-Track really is. Dependency-Track is a platform to identify and reduce risk in the software supply chain by leveraging bill of materials. It is an OWASP flagship project. It is used by thousands of organizations worldwide, ranging from financial service providers to government agencies and more. Dependency-Track itself does not scan binary artifacts, build manifests, source code, or repositories or anything like that. So it's not an SCA tool, and it's not really a scanner either. Instead, it ingests inventory information from bill of materials. So Dependency-Track really puts inventory first, if you will. This also has the nice side effect that Dependency-Track is ecosystem agnostic. So it does not really care which language, package manager, or packaging format you're using, as long as the inventory information is provided in a canonical format. For example, CycloneDX. Quick overview of how the platform works on a high level. First, you either acquire or generate a BOM. You can do that by using the various tools that are available, for example, in the CycloneDX tool center, or like you acquire it from suppliers of yours. The BOMs are then ingested into Dependency-Track. This can be done by uploading them via web UI or via automation using the REST API. And there are also like various integrations around the REST API that the community has built. After successful ingestion, the data is then analyzed for various types of risk, for example, known vulnerabilities, outdated components, license compliance, and all sorts of policies that you may want to enforce. After the initial import, DT will continue to analyze the data at least daily. This is configurable because like BOMs are generally static, or the data in them is generally static, but all the data around it that you are analyzing that BOM data with, for example, vulnerability information, is of course not static. It changes from day to day. New vulnerabilities are added, existing ones are modified, and so on. So it's important to keep rechecking and reanalyzing the data. The platform also emits various kinds of notifications for various events, for example, whenever a new vulnerability is identified. And additionally, we also have integrations with external vulnerability aggregators such as, or issue aggregators such as Jira or Defect Dojo. This is kind of easy to set up for internal products because first you control the build. You can store the BOMs just as part of as a build artifact as part of a build pipeline. And submitting a BOM to Dependency-Track really is just a byproduct of the automation you already have. So it's kind of simple to set up. but it's very hard to do for external products because even if the vendors that you have provide a BOM, you still have to go out of your way to actually locate the BOM, download it, and store it somewhere, then upload it to Dependency-Track. And every vendor uses different means to host their BOM. Like maybe they use an artifact registry or like an OCI registry, sorry, or just their public website or a customer portal. And all of these things may have different authentication and authorization mechanisms. It's really a mess if you try to do this at scale. Yeah, so you can do this manually and you can script this, of course, and this works for like tens or hundreds, possibly even thousands of projects or products. But once you reach into the tens of thousands or hundreds of thousands, or God forbid, even millions of products that your enterprise has, this gets out of the hand quite quickly. Another unfortunate reality is that, I mean, let's face it, users don't really care about BOMs, and dealing with them just complicates their work. BOMs are a fantastic means of communicating information that is relevant to the supply chain, and it is very relevant to what Dependency-Track and other platforms like it try to do, namely automate risk analysis. But in reality, like analysts, lawyers, and most certainly even software developers couldn't care less about them. What they really care about is the data within them and what that means for their business or their product or their project, sorry. So we're aiming to break down some of these hurdles by integrating with and most prominently consuming from T. What that means in practice is that instead of uploading a specific file like a BOM file, clients should be able to provide just a TEI, so the transparency exchange identifier of a product along with the product version they're interested in. The diagram I show here is obviously very heavily simplified, so it fits on one slide, but I think you get the idea. So given this TEI identifier and the version, Dependency-Track should then be able to automatically use T to discover relevant artifacts. For example, BOMs, CLEs, VDRs, and VEXs. And while the rest of the process is still the same, this already takes a lot of the mental burden and a lot of the heavy process in front of this away from the user, right? It's very easy, and it should have been this way for like from the very beginning, I think. It also simplifies automation use cases because now the system triggering an import doesn't have to have the BOM at hand anymore. So for example, your CMDB, your deployment automation, perhaps even your Kubernetes operators that scan the deployed deployments in your cluster, they can simply inform DT about the software that imposes a risk on your organization, and that is the software that is actually deployed and being used somewhere. Yeah, and then from then on, Dependency-Track can take care of the rest as shown in the diagram. And once the initial import is completed, Dependency-Track can continuously check whether new artifact versions are available and automatically ingest them. Or, I mean, at the very least, DT can notify users about the existence or availability of new artifacts and then offer to ingest them after explicit approval. I think both ways are feasible to do and depend on requirements, of course. We figure this will be particularly useful for artifacts that evolve over time, namely, again, CLEs, VDRs, and VEXs. It shouldn't take manual lookups or a vendor sending you an email to put an updated VEX to use, for example. It should be much more streamlined. And the end goal really is to boil this entire process down to tell me what product you use and I will track its risk. It should be as hands-off as possible and it should pretty much run on autopilot. And the fact that BOMs and other transparency artifacts are involved at all should merely be an implementation detail to the user, just like TLS certificates, for example, are an implementation detail of securely accessing a website, which is to say, in the best case, users don't know about it at all. And being able to rely on a standardized exchange mechanism like T brings us a lot closer to this vision, I think. Another pleasant side effect of this for us in particular is that retention of transparency artifacts, such as BOMs, can be decoupled from the processing in Dependency-Track. Because one thing about DT is that it does not keep the original BOM around after it is ingested. So if users do not store the BOM separately, they are lost, right? And that makes actions such as re-importing a BOM quite hard. For example, if the BOM was faulty for some reason or the import failed or whatever, that makes it really challenging. And as far as the platform is concerned, keeping data around for longer than it is actively being used is a waste of space. So if you delete a project in Dependency-Track, the data is gone for good. However, there can, of course, be situations where users may want to import an old version of the product, at which point it would be super convenient if DT could just magically discover those on demand, right? For example, using a standard like T. Another aspect of T that is easily overlooked, I think, if you look at it from the very top, is its like enablement of sharing common lifecycle enumeration that was mentioned a few times already in this con. For platforms like Dependency-Track, which is supposed to track risk, right? Product lifecycle information is kind of crucial. A product or component entering end of support or even end of life status can be a huge risk to an organization. Yet the industry is lacking a reliable way to represent this information and making it available. And if CLE would take off together with T and be adopted by a majority of the vendors and publishers out there, we could finally have a clear, reliable source for this information, which in my book would be beneficial to literally everyone involved. And incidentally, Dependency-Track has a major version transition on the horizon itself. It's transitioning from version 4 to version 5. So we too are scratching our heads at the moment as to how to best inform consumers about the phase out of the old major version. So really, we need T and CLE about yesterday. But not only will the T consume from T, we also believe it should publish to it. As you can see here, this is one very central piece or a very central feature of Dependency-Track. It's its auditing capability. In the screenshot, you can see I marked the vulnerability as not affected because the vulnerable code is not reachable. And I indicated that I as a vendor will not publish a fix. In an ideal world, my analysis decision would automatically trickle down to consumers of my product so they don't need to deal with the finding. And DT can already export such analysis to VDR and VEX files, but now we're back to square one, right? Where do those files go? How do I make them available to customers and consumers? And how do I notify those about the new VEX file being available? With a system like T in place, again, we could let users publish their audit decisions such that they are available to their users automatically. But since DT will already connect to T anyway, it can make sense to publish other artifacts through it as well. For example, in particular for internal use cases, clients could upload a BOM that was generated as part of a CI/CD pipeline run to DT, and DT will then take care of publishing that to T. Because it's like generally undesirable to orchestrate multiple sync systems in a CI/CD pipeline. It gets kind of complicated when one thing fails, the entire pipeline fails, etc. So we could offer a more streamlined experience, so to speak. I'm above time, I think, but just one last thing here. We are really excited to dogfood these things because what I told you about is just the user or the end user facing things. But we are a bit selfish about this, of course. And we too are acting as a vendor who's like distributing a product to users. And we too are currently missing a way to distribute and notify users about BOMs being available, VEXs being available, etc. So we think it would be absolutely fantastic if Dependency-Track could automatically monitor itself. And we could use Dependency-Track to analyze and share VEX and VDR files with the user base. Yeah, that's it. Thanks.
Thank you very much, Niklas. And now over to Viktor. Are you ready?
I am indeed. Thank you, Olle. Assuming I can be heard.
Yes.
Let me see if I can share my screen. Is that visible to everybody? I'm going to assume that's a yes. To Niklas' last point about dog feeding, I think that kind of ties very well and generates a very good segue to what I want to speak about today, which is how SBOMify, which is the company I've created, fits into the T ecosystem. So just give you a quick backstory. It's going to be a slightly different talk than the previous talks. And so I've done a few companies, and the reason why I got involved with SBOMs was because we started to get requests in one of my companies for SBOMs from our customers. So I'm the company. I'm also part of one of the CISA working groups where we do generate a reference implementation for SBOM. So in my company, Screenly, we provide what's called secure digital signage, which is the fancy industry term for display management. And a lot of the companies are very security conscious. And what really ties them all together is that they are security conscious and that they really value security. And last year or early this year, I started getting involved with the Secure by Design project, and I'm sure many people on this call already are well familiar with Secure by Design. And one of the things in Secure by Design is the call for radical transparency. And this might sound like a bit of a tangent here, but this ties back into the T, because as we started working with SBOMs and generating SBOM, we realized it was actually a massive mess, because people new to SBOM, they think that you have one SBOM for a product and off you go and that's it. And the reality is that even for a small product, you're going to end up with 10, 20, 50, 20 SBOMs for even a relatively small product. And as we kind of entered its space, I actually created a new product called sbomify to solve the problem for Screenly. So going back to Niklas' point of dog fooding, I actually created this product to kind of solve the problems we had at Screenly to be able to be compliant with Secure by Design. And going back to Ole's point about this CISA sharing primer, speaking about automation being paramount in a mature SBOM lifecycle. The reason why I really got excited about Project Koala, or the T project, was that it provides a standardized framework for how we can share SBOMs, and that's going to be paramount to this becoming widely acceptable and widely used. And to me, the way I see of it is T is really kind of an S3-like way of consuming SBOMs, or sorry, writing SBOMs, and then we have a discovery piece on top of that. So going into a little bit then why I think it's important and why I got involved with this is because sbomify is a hub for SBOMs, both for sharing and for reading. It's essentially a way for a company to share SBOMs with a stakeholder, be that an internal stakeholder or an external stakeholder. And as I got involved more and more with this, involved with Project Koala, I realized that our vision of the world aligned very well. And that's why we want to aspire to become the first T-compliant platform out there that people can use as a service. So what's interesting is that we had already come up with the same structure internally of how to structure this. And then when I read the documentation of the T outline, the early outlines, I realized that the structure we had created for how in the real world we were to build and ship SBOMs and group SBOMs rather, it really aligned very well with what's been done in the Project Koala world. So in sbomify, we have a concept of product, project, and components. And that, as you can see in the next few slides, kind of aligns with the thinking about Project Koala. But what really made me excited about Project Koala was when you're selling a physical product, like a product like this, you have a barcode, and Olle alluded to this already. That really drives a lot of value. Being able to discover a product using a barcode drives a lot of value. And I think that the good analogy here is from Alan Friedman from CISA. When you go into grocery store, you can pick up a grocery list and see what's actually inside a given product. You can't do that currently today, but by tying together a software product barcode or a box product and do the discovery through the reading that barcode, that allows for a lot of power of actually enabling consumers to understand what goes into the product. So if you're looking here at the mapping that we have done previously to getting involved with Project Koala, you can see it kind of loosely aligns here. There'll be some abstraction layers on top of this to kind of marry the two structures. But our aspiration is to solve that problem so that consumers can use our platform and use the APIs and just consume those APIs, and be able to allow for people to adopt here and without having to run their own infrastructure. And that's really the goal for us. So we are very active in the community and being part of developing the API specifications. We're extremely bullish on this model. And there are, I would say we're still early days in the API specifications, much to Ole's point, but I think we are getting there. And this whole idea of collections, leaf, and product makes a lot of sense to us, particularly when you map it to the discovery part. So what we have today is a GUI that sits on top of our web interface, our GUI, that allows you to manage, group, and consolidate SBOMs and in logical ways. There is also a GitHub Action module that allows you to automatically generate SBOMs in your CI/CD pipeline or whatever pipeline you're using. It's CI agnostic. It can also do augmentation enrichment, which is important because you actually want to have a complete SBOM. And what we're building now is actually helping you create a more complete SBOM, particularly with the license compliance directly in your CI/CD pipeline. So this is kind of a quick overview of what we are doing. Our aspiration is to become kind of the first SBOM service out there that can offer you TIA as a service and offer it in dual mode, where you can both use before the TIA standard is ready out there. You can leverage our existing platform, build, generate SBOMs, and download them and share them with your stakeholders. And then as the TIA platform becomes ready, we can be there, part of that. And then what's really powerful with that part is then as this ecosystem becomes mature, much to the previous point from Daniel about a Dependency-Track, you can then use that ecosystem interoperable with other TIA platforms so that we can be part of that world together, and that integration between multiple TIA platforms can work together. And that's all I had. So I'm going to save some time for the Q&A later. And I think back to you, Olle. Thank you.
Thank you very much, Viktor. It's exciting to see how you're embracing T. Let's see if I can. Okay. We're going to jump over to Piotr. When we started this work, I got in contact with Piotr, and he kind of in a very silent way said, we are the reason that all of this work started. So tell us more, Piotr. Over to you.
Yeah, hello. Yeah, I check if I can share my screen. I'm not able to do it. I think
I have your slides, Piotr, so unless you change them.
okay. So I'll tell you. Okay. Yeah. So yeah, when I started, when I first learned about the TEA, I saw the use cases, and these use cases are very different from what I have. So Olle, next slide, please. Yeah. So first of all, I wanted to explain a little bit where do we stand in. So Apache Log4j has three characteristics. First of all, it's open source. So we don't have boxed products. It's a library. So we don't deliver to end users. We deliver to our developers. And it's in the Java ecosystem, which is quite evolved when it comes to dependency management. We are a little bit all over the ecosystem. We have a Log4j API, which is a library which is used by other libraries. It means this is one of those deeply nested dependencies that are dangerous. If so, I don't know if you know, but most software supply chains attacks goes through deeply nested dependencies. There is Log4j core, which, well, application developers choose to use it. So that's easy to discover, actually. Log4Shell was easy to discover because at least application developers know that they have Log4j or not. And we have also extensions that use Apache Kafka, MongoDB, and so on. Next slide, please. So we have a lot we are in a lot of places. So yeah, I wanted to start with a little bit of a provocation, which means, do we really need SBOMs in Maven? Well, yes and no. So Maven has a file that's called a project object model. It contains only the direct dependencies, but the first feature that was implemented, we can resolve that. We can have an effective POM that gives you all the dependencies you'll ever need. So if we need SBOMs, it's for interoperability purposes, or just to correct errors that other suppliers have. So our dependencies can have errors in the POM files. We can correct them. Next slide. The previous one. So yes. So what we currently do is, of course, we publish SBOMs. We use a CycloneDX Maven plugin, which goes to Maven Central. And well, one of the interests I have in T is, yeah, okay, you are publishing something that must be ecosystem independent, and you do it in a way that's ecosystem dependent. Well, so that's motivation one for why we would use TEA. Next slide. Okay. Now regarding what does it mean an SBOM for a Java library developer, Well, libraries are easy to manage dependencies because we don't actually embed those dependencies in our releases. So whenever we have a vulnerability, we are not affected by it. So we don't have to do anything. So an SBOM for us is a way to share additional information, to share links to our VDRs, links to our vexes, links to the lifecycle information that was mentioned before. Next slide. And here is the second usage I find useful for TEA. Log4j actually doesn't just publish an SBOM like many other projects. We looked at the result of what the plugin gave us, and we said, hey, but here in the standard, I find a lot of nice features like sharing other documents. How can we do that? Well, it wasn't possible. So we added a link to the CycloneDX SBOM and waited and waited and waited to see how many people discover that we are publishing a vulnerability disclosure report with all the CVEs that were published against Log4j. Honestly, I must say that we don't see the effects. Probably nobody is reading that. Next slide. One back, please. Yeah. Well, a third thing for which I think TEA will be useful for an open source library is that we are open source. We if we need to publish vexes are additional work. Nobody pays us for that. People can usually just read the source code and discover themselves if we are vulnerable or no. So yeah, my first, when I heard about vexes, my first impression was, first, we are in Europe where vexes are not such a big deal. Second, it's a lot of work. But then I discovered that, yes, many of our consumers are open source applications like ourselves. So an open source library might not need vexes, but we could produce them so that our friends from other Apache projects that have application is alive. Next slide. Yeah. Okay. So after some time, I got convinced that yes, vexes are important, even for an open source library, so we can help other projects managing their vulnerabilities, especially open source one. I don't really care about commercials one. They can make the research themselves to see if a CVE is exploitable. But for our open source users, I would pretty much like to do some real information. So we can produce vexes, we can produce fake vexes in a library saying, we are exploitable, just upgrade. Yeah. But, well, if we are going to produce real vexes, there's an option one, which is utopic, that somebody will pay us to do that. We don't think it will ever happen. We can produce vexes if it's fast. So it means that whenever a CVE happens, all our direct dependencies inform us that this CVE is exploitable or not exploitable in their product. We have an automatic system that gathers all that information, makes a PR, a little bit like dependable PR, and says, you have a CVE in Snakeyam. Well, we actually also use Snakeyam as a transitive dependency. But the direct dependency Jackson that uses Snakeyam says that they are not exploitable. Cool. Then I can produce a vex saying that we are not exploitable, because all our direct dependencies say that it's not a problem. Next slide. Yeah. So, well, these were 3 points of view on what T can do for an open source library. So I wanted just to summarize. Yes, we can live. We are in the middle of a Maven ecosystem. We can very easily live inside the Maven ecosystem and never produce information that the rest of the world understands, but it's nice to do it. And T is a way to distribute that. We do have vulnerabilities. We would like to report them in a nice way. The NVD, if you know, is a little bit overcharged. So we would like a service where you ask, is there a vulnerability in Log4j? He says yes, and this is the data. And the third application we would like to use TEA is to have vulnerability exploitability reports, which we can do very fast and very precisely. Because if we can connect to TEA services of our direct dependencies and they provide us with the necessary information, We know the code inside out, our code. So we know how we use direct dependencies, and we can very, very easily answer in half an hour for each CV reported. Yeah, that's all for me. Thank you very much.
Thank you, Piotr. It's very interesting to see the different points of view here. It's time we move on to the question and answers. I'll ask all the speakers to turn on your video. And if you have any questions, please, in the audience, turn on video and ask. It's very, very silent. Okay, we got a question in the chat. How does Dependency-Track and T deal with confidentiality issues related to supply chain components and VEXes? Information confidentiality is an issue because of potential risk in proprietary information. Who wants to take on that? Steve?
Yeah, I think first and foremost, every part of the API is going to have authentication and authorization abilities. So every single endpoint is going to have auth N, auth Z. So you could theoretically, have your SBOM available to, I don't know, everybody, maybe even publicly available, but maybe your CBOM or your VEXes or whatever, only available to maybe enterprise super support type users, right? Likewise with insights, where you're not necessarily trading documents, you're trading information. All of that is also going to have authentication and authorization built into the API. And then, of course, it's going to be really up to the implementations of that API, the actual products and vendors and open source projects that implement that API, to go down as deep in the rabbit hole as their customers want. So I do believe that maybe during the next KoalaCon, we should probably discuss a little bit more about authentication and authorization requirements, because I do believe that confidentiality is of critical importance.
Absolutely. Niklas, do you have anything to add? What's the authorization scheme within Dependency-Track? Would you be able to handle this?
Yeah, I mean, it kind of depends on how the T implementation dictates access, right? Dependency-Track, I would assume, would have multiple access or multiple accesses, that's the correct plural, I don't know, configured for like multiple T instances or specific T instances for specific products, maybe even, or specific leaves, if you will. But really, I think this depends on what the implementation of T wants us to use. It's a very generic answer, I'm sorry, but that's the current status I have.
We have to, as Steve said, start working on this and see, but we have been in many different meetings from Piotr and open source, where of course everything happens in the open, to companies in the medical business in the US, where confidentiality and non-disclosure agreements is really important for them. Dirk, welcome.
Yeah, compliments for all this, and also compliments for the sanity and the level of transparency and simpleness. My question is really sort of like about transitive dependencies, both in open source and in commercial open source. So you have a package, let's say log4j, which in turn depends on all sorts of other things, and you're distributing that. And at some point, basically, I think it's unavoidable that significant numbers of these packages will be signed by whomever releases them. And then we sort of like get the complexity is that let's say an organization, even an open source organization like the ASF or a commercial company, even though you may be quite open to digitally signing a software SBOM and saying it depends on these versions of this, and the other, you of course are a lot less inclined to then include the things as such and actually sign those too, even though arguably that is actually legally what you're signing on to, especially with the product liability directive taking hold. What is sort of like your general thinking on those things when sort of like you're structuring those? Are you leaning towards sort of like signing these things by references, or do you expect sort of like these large aggregate packages which some talk about and have these sort of like distributed and signed in aggregate?
That's a very good question. We haven't really started with the digital signatures and those problems, but you are very, very welcome to join us for that discussion. What I've started is a very simple discussion on digital signatures on parts of the T API and the artifacts themselves, which is currently in a pull request in our GitHub repo. But I'm looking forward to that discussion.
Yeah, if you add something, so one of the things we discussed some time ago is in the example of Log4j, there are a lot of repackaged versions and so on. So signatures are a useful thing to know, and the TA in general, so that a customer can know if he gets the original Log4j core or a refurbished version, which probably improves security. I don't know, but it can also make things worse.
Oh yeah. There's a lot of discussions about provenance and separating versions. We have another question in the chat. Don't see any raised hand. What is the timeline goal in terms of T development and delivery for the desired end state? Well, we have two phases. Phase 1, which is artifact distribution, basically, and phase 2, which is inside. And we believe phase 1 will be ready for a hackathon early next year. Then we will have to take the feedback and take another round of discussions and improve all of our APIs and data models and so based on the implementation experience. But we're hoping to forward that version of T to ECMA for standardization at the end of next year. That's the goal we're working on. And then we'll start with phase 2, the insights, which will be a very, very interesting journey, where I think actually we will steal a lot of ideas and concepts from Dependency-Track, but don't tell them. We haven't told them yet about stealing that. Anyone that wants to add something to that question about the timeline and delivery?
The more participation, the better, because it does help us achieve that timeline that we are so aggressively targeting.
Assuming there isn't much feature creep, I think I'm optimistic about the timeline.
Bill, you have hands up.
Hey guys, so I just put it in the chat too, and we talked a little bit about it last Friday, because when the whole thing with SBOMs came up, with in digital signature, signing the SBOM or other artifacts brings another interesting twist to it, is that our legal team is getting leery of wanting to give out things like SBOMs and other kind of data without some sort of disclosure, because as we discussed Friday, what the level of accuracy of an SBOM can be really tough to measure, because how deep do you go? How far down that rabbit hole do you go? Especially when it comes to commercial components where you may not have insight into farther down. So I guess my question really is, in T, is there a way that something like that disclosure or whatever, or any kind of thing could be represented as an addendum, an amendment, an attached document, something like that, that basically says, hey, yes, you're getting this SBOM under these conditions. And is that something worth considering, or is that outside the scope of what T is trying to accomplish?
The CycloneDX attestations, CDXA, allows organizations to attest to anything. whether it's standards, regulation, internal policies, right?
Okay.
And unlike signatures that are used for artifacts that are mainly used for authenticity purposes, CDXA actually does have the concept of signatories. So in jurisdictions where both either digital signatures and or electronic signatures are valid signatures, legally binding signatures, that capability can optionally be used. So if the legal team wants to attest to saying, hey, these bombs are available under these conditions, we followed X, Y, and Z to do that, but we do not, we do not guarantee they're going to be 100% accurate, or whatever kind of statements the legal team wants to do, and then sign that would be your prerogative, but it would be in fact supported.
Gotcha. Cool. Thanks.
Yep.
So with that, I think we're getting close to our end. I thank all very much for attending. This webinar will be published on YouTube soon, and you'll find there and on the CycloneDX website and our Slack channel, you'll find us if you have further questions. You can, of course, also track us down on LinkedIn or other social media. So thank you very much for participating, and see you at next KoalaCon.